Hello. Okay. So today we are going to discuss a very important concept of marketing research, which is conjoint analysis. So you must have heard of this word conjoint a number of times in your marketing research classes or research methodology classes. And now, conjoint analysis is generally used to identify the the attributes which consumers are seeking in particular products and services. It also helps us in identifying uh, which attributes are important, which have less important, or which are uh, entirely irrelevant from the customer's point of view when they are making their purchase decisions. So, as the name suggests, conjoint. So it is. Uh, it is nothing but the joint consideration of various attributes within a product. Now, we have various applications of conjoint analysis. One of the primary application is to identify important attributes which consumers are looking for. Secondly, we can also analyze uh, what attributes your competitors are offering and where do you lack in terms of your offering, uh, or where your strength lies in context to the competition. So these are some applications of conjoint analysis. Now, in conjoint analysis, there are various methods. Today, I'm going to discuss a full profile and partial profile method. They are both interlinked, so it will be easy for you to understand. So, at the start of any conjoint analysis, we have to first create an experiment. So, now what is an experiment? Experiment is basically the research design you are creating based on your say research objectives. Okay, so let me demonstrate it to you. So I'm creating an experiment object here, which is okay. Suppose I am creating an experiment to analyze how consumers differ in their perception of mobile phone features. Okay, so there are various attributes which we can assign to mobile phones. For example, one of the features which is important to consumers is the weight of the phone. So let's say one of the attributes is weight. Okay. Now this weight attribute can be explained uh, using various levels. For example, weight can be say represented in grams or high, low. So in this way, so we have to create levels. So let's say 150 grams, and the second level is 200 grams. Okay, so I've created one attribute with two levels. Second attribute can be say price. Now this attribute can take two values. Let's say price is equal to concatenate low, high. Okay. Next attribute can be warranty. So warranty can take two values. Let's say one option you want to give to respondents is 2 years warranty, and the other is 5 years warranty. Okay. Another attribute can be, let's say, battery life, which is, let's see, One phone is offering 10 hours battery life and the other is offering 20 hours battery life. Okay, so this is my basic research design. So my research design or my experiment will include all the attributes which I want to put in this study, and each attributes will have some levels. So there might be some error here. Let me find out. Right, so I didn't put the C here, concatenate, that was the error. So I'll run the function. Okay, so I can, for visual purposes, I'm breaking this function here so you can understand it properly. So if you want to break the function, just break it after the commas. Alright, so now I have this experiment for my conjoint analysis. Now this, if I want to look at this object, what is this? This experiment uh, gives me different profiles of the levels based on the attributes. For example, let's say in the first profile, I have 150 gram, low price, 2 year, and 10-hour battery life. The second profile, I have 200 gram, weight category, low price, 2 year, warranty, and 10 hours battery life. So this experiment or this grid tells me that there are 16 possible combination of all the products attribute and their levels. Now how do I come up with the number 16? You see there are 4 attributes and each attribute has 2 levels. For example, let's say first attribute has 2 levels, so 2 into 2 into 2 into 2. Okay, 4 attributes, 2 levels. So if I run this, it will give me 16. So the possible combination for my experiment is 16. Now, what are these profiles? Suppose I want to ask a customer about his view on a phone which has 150 gram weight, low price, 2-year warranty, and 10 hours. Okay, so the respondent can weigh upon various say levels of each attribute, and based on his perception he can rate this mobile phone which is in profile 1, or he can rank it, or he can assign a score based on his perception. So if I am conducting this experiment, each respondent will have to say give scores to 16 various combinations. So if I want to conduct my experiment like this, it will be known as a full profile experiment. Um, Now how do we proceed with the experiment or the research design? The second important thing which we require for conjoint analysis is that the all the profiles should be independent from each other. So how do we determine that? Whether this profile is different from this profile. Okay, so first profile is different from second and third and fourth and like that. So we can check it using this simple function, correlation of alright. So before proceeding, I have to load the conjoint package. Okay, if you don't have this package, please install it. correlation, and experiment. Okay. So what does this tell me? It tells me that um, all the levels or all the attributes are independent from each other in my experiment. Okay. So this is the prime requirement for the full or partial design. Now, if I want to proceed with this sort of design, I will call it a full profile conjoint analysis. And if I want to, let's say, go for partial design, I can do that also. Now let's create a partial design which is equal to CA factorial design. Data is experiment, comma, type is equal to orthogonal, and seed, we will default seed is 1 to 3. You can keep put in your own seeds, it's your choice. Okay, and then run this function. Now what does this factorial design gives us? What is the output? Let's look at the output. All right, so it is giving me 8 profiles: 1 2 3 4 5 6 7 and 8. Now what are these profiles? Again, these are different combinations of these attributes and their levels, um, which will help us or help the consumer in deciding which combination is best suited for him, or how do he perceive different combination um, given these 8 combinations. Okay, for example, let's say if I am preparing a questionnaire now based on partial design, then I will create 8 questions. Okay, and I will ask each respondent to rate these profiles again based on some scores or ranks. Okay, so my question can be like this: mm, uh, kindly rate this phone based on various features. Okay, the features I will give him: 200 gram, low price, warranty 2 years, and battery life. So he will give me a score from, let's say, 0 to 100, or he can assign a rank out of these 8. How do he rank this phone? How do he rank this phone? And like that. Okay. Uh, Now, since my experiment is set up, um, I have to create one other object, which is the encoded matrix of this partial design. So I can do that. Partial profile, okay, and CA encoded design for my partial design experiment. Okay, so if I look at this object, these are nothing but the encoded, this is the encoded version of my partial design. Again, if I check the correlation for my partial profiles or encoded profiles, it will give me zero correlation between various attributes. So partial profile is well suited uh, for those analyses when we have large number of attributes with high number of levels. Okay, for example, let's suppose you have uh, a fifth level here, or fifth attribute with four levels. So the number of profiles you have to create is 16 into 4. Okay, 64. So consumers sometimes they find it difficult to say analyze these much of questions. Okay, so to reduce the number of questions or profiles, we use partial design method. Okay. Now, so this is my first requirement, so I am labeling it here. Okay, requirement number 1. Okay. If I want, I can also save it as a CSV. Okay. So I'm removing this correlation here. Okay. The second thing I require is a data frame which contains all the levels. Okay. A data frame which contains all the levels. So what are the levels here? These are the levels. Okay. So I will select these and paste here. Okay. So this object levels will contain all the levels which I am using in my study. Okay. These are required for running conjoint analysis. That is why I am creating this. Okay. Now I am converting it into a data frame. So left.df is the new object which I am creating. So data.frame is the function, and I will put in the levels object and run. Okay. So if I want to have a look at my left.df, these are my levels, 8 levels. Okay. So this is my second requirement. Okay. The third requirement is data. So I have my data in my working directory. Let me give you some overview of this data. So this data set contains responses from 210 consumers. So we offered them questions, or we gave them questions for all 8 profiles which are in my research design. Okay. Okay. So each respondent was asked to give his rating to each profile from 0 to 100. So if you look at this data, now you will observe this is the first column. This is the ID for each respondent, and these are different profiles. So I have used partial design. So I will have 8 profiles. If I am using full profile, then I will have 16 profiles. Okay. So each customer or each respondent has rated the profiles. Okay. For example, this is customer 1. He has rated profile 1 as 73, profile 2 88, profile 77, like that. Okay. So this is my data. So I will import my data here. So data is read.csv, file.choose. So my data is in the CSV file. And in my working directory, okay, so my data is imported. I can just verify that. All right, so this is my data. Okay, so this is my third requirement. So always remember that you don't need to create experiments here. You can create say these objects. For example, you can create partial design in your Excel sheet. You can create partial profile in your Excel sheet. You can create this left.df object in your Excel sheet, and then import all these you can say objects. Okay. And secondly, if I want to export these objects, I can do that too. Okay, I can just put in here uh, write.csv. Okay, and maybe I want to, let's say, put this object into a CSV file, so I can profile dot CSV. All right, so I can save these objects too. So I'm not saving this now, I'm just showing you how you can do it. Okay, so now I have all the required things to proceed with my conjoint analysis. So this is my requirement number 3. So I have already loaded the conjoint package, so I will use the function here, conjoint. Now this conjoint function requires 3 things. Okay, if you look at the syntax here, it requires y, x, and z. Y type is the kind of data you have. If you have rank data, you can specify y type is equal to rank. If it is score, you can specify y type is equal to score. Okay, now what is y here? Y is my data which I have collected from respondent. Okay, so data, my data starts from so I need all the rows of my data. My data starts from the second column till the ninth column. This is my y. I will put in now x. X is my profiles. Okay, partial profiles. So par profile, and I need all the rows. Now my profiles are from first column to fourth column. Okay, so there are 4 attributes, so 4 columns. Okay, then z is equal to left.df. These are this data set, this data frame which contains all the levels. Okay, so this way I can run the conjoint analysis. I'll rerun this. All right. Okay, so my conjoint analysis has run. There are so many graphs here which automatically appears. Okay, okay, so the most important graph is this one, importance, average importance. So according to my data, the consumers are giving most importance to the battery life, followed by warranty, and then price, and then weight. This I can confirm from this table 2 here. Okay, 7.28, 0, 0.04, 0.73, 0.2. So these negative numbers do not mean that the customer has, they have negative views uh, regarding price or weight. They think that they are not as important as warranty or battery life. Okay, so according to the analysis, battery life is the most important attribute. Now let's move down. So these are part worth utilities. Okay, so if I observe here, there are equal number of consumers who are giving importance to 150 gram uh, weight and 200 gram weight. Okay, similarly there are equal number of people who are giving say importance to low um, price levels and high price level. The only differentiating factor here is the battery life, which is because of its importance. Okay, even in battery life, if you see, there are equal number of people who are giving importance to battery life here. Okay, so although number of people who are giving importance to these or not giving as much importance to these attributes, it's same, but overall the most important factor is the battery life. Okay, so maybe if you are thinking, let's say if you want to get something out of this analysis, suppose you are offering you are in near future you are going to offer a new phone, you should focus on increasing the battery life. Okay, uh, price price is not that much important. Okay, price and weight. Okay, so you can play with these attributes. You can maybe increase the weight of your phone to increase the battery life, and you can even charge somewhat higher prices to cover the cost. Okay, so this is how your conjoint analysis works. So this data set and this experiment I have created on my own. All right, so it has it may contain some researchers bias, but however in real life you will get very interesting result. uh, Now, how can I further this analysis? This conjoint package gives me freedom to create clusters out of uh, these consumers or respondents. Okay, so let's see. So suppose I want to segment my consumers based on uh, their utility perceptions. Okay, so segment CA segmentation. This is the function. So it requires again y and x. So I'm giving it y and x and copy it from here. Okay, so data is same, so it makes no difference. And now I have to give it the number of clusters I'm looking for. So you already, if you are familiar with cluster analysis, we have to define the number of clusters we are looking for. So this CA segmentation function uses k-means clustering method. So let's say I'm looking for 2 clusters. Okay, it's done. So if I look at this object segments, so these are my outputs. So the most simple output here which we can easily interpret is this one: cluster of sizes 122 and 88. So there are two types of customers. In one cluster there are 122 and in another cluster there are 88 consumers. Okay, I can also create a visualization out of this. I'm using this package Facto Extra. Okay, so first I will have to extract some objects from this segments. So I'm giving it a name. Cluster is equal to segments dollar. Now this segment is this one. Okay, so segments dollar SCGM. This is the object I require to create my visualization. Okay, so I will use this fis cluster function, which is in a Facto Extra package, and then I will use this cluster, and I also require data. Data is in my segments object. So segments dollar utilities. Right. If I run this function, okay, so these are my 2 clusters. Okay, but there are some overlapping consumers here. Okay, so maybe I can increase the number of clusters. Let's see what happens. Okay, yeah, this makes more sense. Okay, so now we can easily divide our consumers in 3 clusters based on uh, our analysis. This division is based on the utility scores for each consumers. Okay. Now, if you want to proceed with further analysis, you can maybe look for the attributes which a particular cluster of consumers seeks. Okay, so you can again do a conjoint analysis for one particular set of clusters. Okay, so this way you can do conjoint analysis. Say if you have your data in Excel sheets, okay, you can easily import that data and create objects. Okay, so you have to create these objects. One is profile, one is the data, okay, and the other is the levels. Okay, so these three things you require for your conjoint analysis. One thing I want to mention here is, if I want to mention here y type, I can mention it. Okay, this will not affect my results. Okay, but if you are using rankings, then maybe you should go for it. Okay, so this is a simple conjoint analysis. So if you are using partial design, you can easily do it using this script. Or if you want to go for full profile, then the only change you have to make is in uh, your data. Okay, you would need then 16 profiles, and each consumers will require to evaluate 16 profiles. Okay, so this is how you can conduct simple